All right, well, hello class. I think I'm recording here. It's been a while since I've done this. So here we go on chi-square. I want to give you an example of how to do the chi-square using a task from the book, the lab part where we get our labs. So what I picked was task number 1. And it talks about research on time pressure and detachment from work. So I'm feeling a lot of time pressure in my job right now, and so I thought this was a really great question. So what I did is downloaded the data, and this is my SPSS. So here, when we do chi-square tests, we're doing these because we have categorical data. Or we have data that's nominal, right? And we've kind of sorted it into categories or frequencies of how many times something has happened in a particular category. So you can see here that we've got categories of time pressure and we have categories of detachment. So if we turn this on so we can see the actual string or the name of the variable here, time pressure, we have no time pressure, right, that variable, and very low detachment. So when we did this experiment with all 1,700 people, 94 of them replied no time pressure and very low detachment. So what this does here is it just separates how many times the subjects responded in these categories, right? And so you can see we have all the possible combinations. So how we do a chi-square on this then is first, because it is in this form and not all 1,700 subjects, down the line here, we have a frequency table that your textbook talked about, and you can see that because we have this column called frequency, so how many times certain things happened. So first we have to tell SPSS that we need to weight all of these cases, because it doesn't know what you're asking it to do. It's used to seeing all the zeros and ones and all the data plugged in individually. This is just a time saver. So we go to weight cases, and you see when you open it up, you won't have this in here, but since I've run it already, you can see that you would need to click weight cases, and you always weight it by the frequency variable because that is the scale, right? That's what SPSS needs. So we say okay, all right, and then we got it all weighted. Now, to do the actual chi-square test, we come up to Analyze, and we go to Descriptive Statistics, and SPSS doesn't call it chi-square, it calls it crosstabs. That was the old name for it. So crosstabs, you click on that, and you will see if you will have open it up and there won't be anything in these boxes. You have to tell SPSS what are you comparing, what's in the row, what's in the column. So what are the two variables? So we know it's time pressure is 1, right? So we'll put that over into row. Doesn't matter if you put it in column or row, they just each need to go in one or the other. So I have time pressure as a row and column as detachment from work. Now the choices, we have exact, okay, and we need to click it as exact. So we continue. Then under the statistics, we want to know the chi-square value, there it is, and we also, because we're not using the likelihood ratio, we're looking at the phi and the Kramers as our effect size, right? So we got to click on that one. So click on that. That's it for this one. Hit continue. Now, under cells, you have lots of things to check. So if this would be blank when you open it, I did observed and expected. We want those. We want the z-test, and we want to adjust it to correct for inflation of our significance, our error. So we check those two. Percentages are sometimes helpful in figuring out how much of the time something occurred, so all of those could be checked. And then residuals, very important that you get the standardized residuals so we can figure out if we have a significance, we got to go figure out where that's at because we have lots of choices here. So you click standardized. Then continue. Now the rest of these don't worry about. We don't need anything under format style, and I don't think you have this bootstrap. All right, we're done. So let's click on OK, and it's going to run our analysis. All right, so here we go. So under crosstabs, you can see that it gives us all of the cases that we have. We had 1,709. And here is the, I don't know, I guess the row and column that we looked at earlier. So it tells you time pressure, right, on this column. And over here is detachment from work. So those are our two, low, very low. And then we have all these time pressures, which we've got lots of them. 1, 2, 3, 4, 5. And then a total. And you can see it put in the percentages, right? So the first thing we want to see, is there an overall association between time pressure and how you're detached from work? And that's our chi-square. That's our test. So here you can see there's the Pearson chi-square. The value is 15.5. The degrees of freedom is 4. And the significance, right, significance two-sided is 0.004. So that's less than 0.05, right? So we do have a significant result, a significant association between these two. Now, we got to go back and figure out where it is. Is it significant between very high time pressure and low detachment, very low detachment, no time pressure and low detachment? So you kind of have to take this puzzle and figure out what is it, which one is it? And that's where our standardized residuals come in. Now the book talks about this, and so does the PowerPoint, that we're looking for values that are outside of the range of plus or minus 1.96. So anything higher than 1.96, right, like 2.2, 3.00 is going to be significant. And anything below a negative 1.96 is going to be significant also, right? Two ends of the tail, positive and negative. So what it's finding is things that are outside in these tails that are significant. That's why we ask for these residuals. So here, 1, that's not greater than 1.96. Negative 0.8, not less than negative 1.96. So we just keep checking these. This one, no. This one, no. This one, no, 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 no. Right here, right? 2.3, negative 2.3, and positive 2. So those are outside in those tails. You can have lots of these when you do a chi-square. Here we only have these two. So what this is really saying is, if you come back up here and look, so under very high time pressure, and this is low detachment, 199 people responded that way. What you would expect, right, in normal life, is that 234 people would respond that way. So we had less, which is why this is negative, okay? Less people responded this way than what we would expect. So there's something significant there. And here we have 354 responded, very high time pressure and very low detachment. And what we would expect was 318. So we had more people respond than what we expected. That's why this is positive. This really helps in your interpretation and how to write it up. The reason I'm not a big fan about chi-square is because this interpretation becomes kind of tricky sometimes. So you just have to think kind of intuitively, logically about what you got and what you would expect. So we had less people than we thought responded that very high time pressure gives them low detachment. More people, very high time pressure, more people responded with very low detachment. So let's go to our write-up because we're done. That's it. That's all the information we need, well, except for this one here. When we get to the effect size, right, we're going to have to look at the phi on this one because we have more than a 2 by 2. We have a 2 by 5, I think we said, chart. So we would look at the phi, and that's the number here is 0.095. That's our effect size, okay? So let's look at the write-up, and I've already done this so we can kind of see what this looks like. Let me make it just a smidge bigger. Oh, that's a lot bigger. All right, so we do have an overall association. There was a significant association. I gotta get this a little smaller. Between the ability to detach from work and time pressure. Now look, I've got my numbers in there to back up that statement. There's a significant result because of this P. There's our chi-square, degrees of freedom 4 equals 15.55, right? P equals, because that's our P. And then I put in the R, which was that phi number, 0.095, indicating a small effect size. So we have a significant result, but a small effect size. And remember, effect size is those small, medium, and large fries. 0.1 is small, up to 0.3 is medium, 0.5 and over is large. So it's very small, really. I mean, it doesn't even hit 0.1. So here's how we interpret that last part. So when the time pressure was very high, right, that's why where we saw the significance, significantly more people experienced very low detachment to work than low detachment. Okay, so we had more people experience very low detachment, right, than very low detachment than the low detachment when they're in this high time pressure. Okay, and if you look at the answer, there's some things there that explain that in terms of how you would do that. You could also put it in as percentages, those kinds of things. But basically, this is telling us that when the time pressure is really high, people feel very low attachment to work. Okay, that kind of makes sense intuitively, right? But it's even more than what we would expect. All right, I think that's all I have on chi-square. I did put up an article that you can read how somebody did that when they were watching movies. So that's always fun to do research when you're watching the movies. So anyway, guys, good luck on this. And as always, give me a shout if you need anything. Bye-bye.